Hi everyone, thank you for coming to this meeting. And for those of you who are still on Teams, it will be nice if you can join the Zoom chat from the chat I sent on Teams because I'm logging into both screens right now. And we are really excited today to have Nicola Rainey to share about data visualizations. And Nicola is data visualization specialist with a background in statistics and data science. She's also a committee member and secretary of the RSS teaching statistics sections. She is also one of the RSS 2024 to 2025 William Geist lecturers who has recorded and delivered talks aimed at 11 to 16 years old on the topic of using data and statistics to shape decision making in medicine and healthcare. And we are really happy to have Nicola over here today to present it. And also this event is co-organized by YASA and YSS. And we're really happy to have all of your attendance and interest in this event.
Okay. Thank you very much, Teresa, for that introduction. If you do have any questions during the session, there will be time at the end to go through them, so do stick them in the chat and I'll try and keep an eye on it in case there's any urgent questions that come through. So what we're going to be talking about today is data visualization. Okay? And as Teresa said, I am a data visualization specialist. So I mainly work with R, Python, and some D3, some JavaScript. But my background is in statistics and operational research, and I've worked in both data science consultancy and industry, in academia, and I'm currently working in government. I've built quite a few R packages as well. So a lot of the examples you'll see today were built in R, although you don't actually need to know any R at all to go through the session today. Okay. So in terms of what this session is about, we're going to talk about why data visualization is important and why you should visualize your data. We're going to talk about how do you choose a chart type. We'll go through some guidelines for making better charts. So we'll look at some examples of applying those guidelines to different types of visualizations. And of course, we'll look at some examples of good and not so good charts. Okay. So to start off with, let's think a little bit about why we visualize data. What is the role of visualization in data analysis and data science? Okay. So I tend to talk about data visualization as almost being like the bookends of any data analytics project. Okay? It kind of has two main purposes. It's usually one of the first things you want to do when you're starting a new project. So you want to do some exploratory data analysis, and you want visualization to be a part of that. And it can help you do things like identify data issues, maybe choose which type of model is most appropriate. But then when you've finished your project and you've done your analysis, it's also usually one of the last things that you want to do. Okay, so you want to communicate whatever it is you found, whatever insights or results you have to someone else. And that might be through a presentation or writing a paper. And data visualization can be a part of whatever way you choose to communicate your analysis. Okay, so I'm going to show you a little example of some summary statistics here. Okay, so thinking about visualization for exploring your data. Okay, so I've got a data set and it has two variables, X and Y. Okay, and so you've got your summary statistics here, okay, that shows you the mean and standard deviation of X and Y and what the correlation is between them. Okay, so if I asked you to try and draw a scatter plot of X against Y, what do you think that might look like? Okay, so if I was going to try and draw a scatter plot of this data, okay, I'd probably start with the correlation. Okay, correlation is very close to zero, which in my head is just a big sort of blur of points with no relationship. Okay, and then I'd look at the mean, X is a bit bigger than Y, okay, but Y is a bit more spread out. Okay, so if I was to try and guess what this data looks like, I'd probably come up with something like this. Okay, just a kind of big blob of points. Okay, but actually, here's 12 different data sets, and those are the summary statistics for all 12 of those data sets. Okay. So summary statistics aren't enough. Okay. So it's really important that you just plot your data and look at it. Okay. Because these summary statistics are not going to give you enough information. So that's why visualization is really important in those early stages of analysis. And in terms of why is visualization useful at the end of your project when you're trying to communicate with someone else, they stand out. Okay. If you're a little bit like me and you sort of read papers and you flick through it and look at the pictures first, the visualizations stand out. Okay. If someone is kind of short on time and skim reading your paper, visualizations are the thing that's going to sort of catch their attention, and might encourage them to read the rest of your paper in a bit more detail. Okay. It can also improve access to information. Okay, so if you can imagine lots of numbers sort of in a big paragraph of text, it's quite hard to read, it's quite hard to compare numbers. And usually if they're written in text, you have to round them in some way, so they're usually less precise. Okay. And it's a really good way of just summarizing information. Okay, so it makes it more memorable. Someone can sort of keep a picture of that plot in their mind when they're thinking about uh, your analysis, compared to trying to memorize lots of figures in a text block. So as a little example, this is one of my sort of favorite charts. It's a very old chart from 1854. And some of you might have seen this before. It's a kind of classic visualization. Okay. So this is looking at the number of deaths from cholera at different addresses in London. So the sort of height of the bar um, corresponds to the number of deaths at that address. Okay. And straight away, when you look at this chart, you can sort of see where are these clustering. Okay. And you can sort of look at this and start to identify where the main location is, okay, that might be causing the issues. Okay. And I really like this chart because it's very old, which means it's quite simple, okay, and it's in black and white. It's not interactive. It's not using lots of colors. So by today's standards of charts, it might look almost boring, but it's really, really effective. Okay. So what we're going to look at next is choosing a chart type. Okay. So hopefully you've kind of understood that visualization is important. Okay. So once we've decided we need to make a chart, how do we decide what type of chart to make? Okay. So the first thing to think about is what is it that you're trying to communicate? Okay. Data visualizations have to serve a purpose. Okay. If you're making a presentation, you have a sort of limited number of slides, okay, or a limited amount of time. If you're writing an academic paper, you might be limited to the number of charts you're allowed to include. Okay. If you're writing a sort of report in business, you're going to have a sort of limited length of number of pages before people stop reading. Okay. So before you include a chart, it's really important to think about what's the purpose of that chart? What is it that you're trying to show? And then does the type of visualization you've picked actually support that purpose? Okay. And is it sort of quick and accurate and quite intuitive? Okay. So one of the ways that you can think about choosing a chart type is to think about the relationship in the data that you're trying to show. Okay. So some of the common relationships that you might be trying to show is something like correlation. Okay. So the relationship between different variables, deviation. So the difference between values and a threshold or an average, for example. Okay. You might be looking at trying to show the distribution. Okay, so what are the sort of range or spread of values for a particular variable? If you've got spatial data, you might be trying to show the pattern of the data across different regions or different locations. You might also just be trying to show the magnitude. Okay, so how big are the values? Or indeed, what's the size of the values relative to each other, or sort of making up a whole? You might also be trying to show the ranking of different values. Okay, so what's at the top of the ranked list and what's at the bottom. Or you might be trying to show how something changes over time. Okay. So one of the things we talked about is making sure that the type of chart you choose supports what it is you're trying to show. Okay, and there's a couple of types of charts out there that people um, sort of love to hate. Okay, and pie charts are one of those. Okay, so why do pie charts have such a bad reputation? Why do people sort of hate them so much? Okay, so one of the reasons that they're not always very effective is that the way our brains process pie charts um, can change a little bit. Okay, so if I was to ask you to look at this pie chart here, okay, so it has two segments. It's a really simple pie chart. It's got two segments A and B. So if I asked you to guess what percentage is segment B, the sort of smaller orange segment, okay, there's four different things you could be looking at in this chart. Okay, so one of the things you might look at is the area. Okay, the other thing you might look at is the angle, okay, of the sort of bit in the middle. The other thing you might look at is the arc length. Okay, so how long is this sort of part of the edge of the circle? And the other thing is the chord length. Okay, so if you were to draw a straight line between those 2 points. Okay, so if you're looking at segment B, it's quite a small segment, so you're quite likely to be looking at the angle. Okay, but if I was to show you a slightly different pie chart, okay, where the only thing that's different is the sort of size of the segments, when we look at big segments, our brains tend to process that as an area. Okay, so the way that our brains process information about pie charts depends on what the values in the pie charts actually are. Okay, so it makes it really hard to accurately compare small segments and big segments. Okay, the other pie chart, ah, the other type of chart that gets a bit of a bad reputation is 3D charts. Okay, so there's a really simple question here. Okay, so if you look at the chart on the left, okay, it's the simplest kind of chart you could have. Okay, just got one data point. So I'm going to ask you a question, and you can post your answers in the chat. But for that chart on the left, how tall is the bar? Okay, what value is represented there? Okay, so we got a few answers. We got something that's about 10. Okay, so there's a couple of way, like easy, there's a few different answers coming through in the chat. Okay, we've got 10.5, we've got 11, we've got 10. Okay, so let's have a little think. Okay, so let's look at the front of this bar here. Okay, so if we draw our little line along to the left, we get something that's a little bit bigger than 10. Okay, so it's up here somewhere. So 10.5, 11 is a really good guess. Okay, but if we go to the back of this bar, okay, you can see that this sort of axis line that represents 10. If we're looking at the back of this bar, that's a value that's less than 10. Okay, so we've managed to plot a number that is at the same time bigger than 10 and less than 10. Okay, which is obviously impossible. So that's why 3D charts tend not to work very well in terms of accurately showing values. Okay, because you have this sort of extra perspective that makes it really hard. Okay? And you can see that again on this example on the right. Okay, the four sort of tall bars here all have the same value. Okay, but because of the angle of the 3D chart, it almost looks like there's a decreasing relationship there. Okay. So how do we choose a chart type that supports the relationship we want to show? Okay, and you'll find lots of examples of these sort of almost like flow charts or chart choosers. Okay, and I think this Financial Times visual vocabulary is one of the most popular ones. Okay, so you can look along and see, okay, what is it that I'm trying to show? Okay, so if, for example, you're trying to show the change over time, okay, how does a variable change over time? Here's some chart options that really support that. Okay, and give you some ideas of charts that might be appropriate. Okay, but it's not just about the type of data. Okay, so although these sort of visual vocabularies and sort of automated ways of choosing charts can be really helpful is not just about the type of data that you have, it is about the actual data that you have and the values that are in your data. Okay, so let's say I have some continuous variables and I want to show how they're changing over time. Okay, a line chart would be a really sort of standard option. Okay, so I might choose something like this. Okay, and that's a reasonably nice looking chart, I think. Okay, it's quite clear, everything's sort of labeled, easy to read. Okay, so what I have here is 4 continuous variables, and I want to show how they change over time. Okay, here I have 4 continuous variables, and I want to show how they change over time. Okay, that chart on the right is much, much harder to read. Okay, but there's no difference in terms of the types of data that I have between those two charts. Okay, the thing that's different is the values. Okay, so sometimes you have to make a chart before you figure out if it's the right one or not for your data. So let's say that we've decided on a chart type. Okay, so we've decided whether or not we need to make a line chart or bar chart, whatever it is. How do we make sure that we design that as effectively as possible? Okay, so how do we apply visualization best practices? Okay, so there's lots of different elements of charts, okay, that we can change and they'll make them more or less effective. Okay, so you can think about things like the layout and the aspect ratio. Okay, do you stretch a chart out so it's very wide or do you make it very tall? Okay, do you use things like lines or points? If you're using colors for different categories, how do you choose what those colors should be? If you're then also using things like symbols, either instead of or in addition to colors, how do you put those into legend? Okay. And there's lots of other elements of charts, things like text, things like the orientation. Okay, so what goes on which axes, um, dimensionality, so how many things, how many different variables do you try to show on one chart? Okay, so we're going to go through a few examples now of changing these different elements and looking at how they are effective. So this is an example of a chart showing the distribution for 5 different groups. Okay, so groups A through to E. Okay, so these are showing the density plots for each group. Okay, and you can see that these charts start to get quite complicated quite quickly. Okay, as soon as you start layering um, multiple ones on top of each other, the colors start to like combine and blend together, and the lines start to intersect, and it gets quite hard to follow the line for one particular group. So what is a quite common approach to do is to split this out into small multiples, okay, or some people call them facets. Okay, so you might have something that looks like this. Okay, so plot each density on a different small chart for each group. Okay, now if I asked you to look at this chart and say, okay, what's higher? Who's is the average for C or D higher? Okay, that's quite hard to see from this chart, okay, because you're kind of mentally trying to draw a line sort of down here and then trying to draw a different line down here in your brain and compare them. Okay, if you want to compare the mean between different groups, the easiest way to do that is to stack those plots on top of each other rather than side by side. Okay, and straight away you can see, okay, actually the average for group D is a little bit higher. Okay, your brain doesn't have to do that extra work in processing that chart. Right. It's quite common when people are making a plot of a categorical variable against a numeric variable to start with a chart that looks like this. Okay, so we've got our categories along the x-axis there. Okay, and obviously those category labels are quite long. Okay, you can't really read any of them because they all overlap. And what a lot of people do here is you think, okay, well, what I'll do is I'll rotate them. Okay, I'll rotate them either 45 or 90 degrees. And then you can sort of tell when people get to this part of the chart because all of their heads go to the side and they try to read those labels. Okay? It's much easier if you put categorical variables on the y-axis, okay, and just put the text horizontal, and it becomes really easy to read. Okay. And I think this is one of my favorite examples of visualization best practices because it's essentially a tiny, tiny little change, but it makes life so much easier for the people who are reading your charts. So there's, I guess, quite a common data visualization question of should the axes for your charts start at 0? Okay, so let's say I am comparing our product with some competitor's product. Here's a bar chart of those results. Okay, if I look at that very quickly, okay, and I don't really pay attention to the chart details, I straight away think that our product is maybe 4 or 5 times more successful. Okay, it's ranked 4 or 5 times higher. Okay, but then you look at the y-axis values and you realize it doesn't start at 0, it starts at 208, and actually this is a comparison. Okay, they're pretty much the same. There's very little difference between the two. Okay, and the reason why it's important to, in this example, start your axes at 0 is because of that sort of quick interpretation. Okay? A lot of people are not going to have the time to spend looking at your axes and making sure they start at 0. So they're only going to look at something for a couple of seconds. Okay? And that's you want to make sure that the conclusion someone gets after looking at a chart for 5 seconds is the same as conclusion if they spent 5 minutes looking at it and comparing the axes. Okay. Having said that, they don't always have to start at 0. Okay, it's one of these classic "it depends" situations. Okay, so this is an example looking at the change in population over time. Okay, and particularly when you're looking at something happening over time, it's not always appropriate to start that at 0. Okay, so with bar charts, it's really important to start it at 0 because the height of the bar is the thing that represents the data. Okay? Here, it's sort of the position of the line rather than the thickness of the line that represents the values in the data. Okay? And if you think about something like population, or another good example is temperature. Okay? If you were to always start those line charts at 0, what you'd do is you'd sort of be pushing those lines up to the top of the chart, you'd have lots of blank space, and everything basically ends up looking like a straight line if you stretch your chart out enough. Okay? So they don't always have to start at 0. You need to be thinking about what is it that you're trying to show. Are you showing change over time, or are you showing values? We talked a little bit about categorical axes, okay, in terms of putting them on the y-axis. Okay, so I've done that here. I've applied one of the best practices. Okay, so let me ask you a question here of, this is looking at GDP for 5 different countries, okay, in 2007. What's higher, the UK or Finland? Okay. It's quite hard. Okay, what I'd want to do is sort of get a ruler out um, and, and put that up against my laptop screen and tell that way. Okay, but if we order the categories from highest to lowest, it becomes much easier to see that Finland is just a little bit higher than the UK. There's an argument that maybe it doesn't really matter because the values are so close, but it's still nice to get that ranking. Okay, and I haven't sort of written down that I've ranked those values or this one is higher, because it's very sort of obvious to a reader, to a user, that they are ranked, so we know that Finland is higher than the UK. Okay. I'm going to look at another example of ordering categories. Okay, so this is a chart of COVID cases. Okay, so this is a real chart that was published in the US during COVID. So it's looking at 5 different counties in the state of Georgia, okay, and the number of COVID cases. Okay. Does anybody notice anything a little bit odd about this chart? Okay. So there's a couple of things that you notice straight away with this chart. Okay, the first thing is when you're looking at the colors. So the colors of the bars represent the different counties, and the colors keep changing orders, right? So this purple first, then orange first, then yellow first. So it gets a bit confusing. The other thing that takes a little bit longer to see is if you look at the values on the x-axis. Okay, so I think for most of us, time only ever goes forwards, right? But here, the time sort of goes backwards and forwards. Okay, so we start in April, and then we go sort of earlier in April, and then May, and then back to April again. Okay, so if I was to say that this is a chart of COVID cases over time, and someone looks at this very quickly, they see that these bars are decreasing, so it looks like COVID cases are decreasing over time. Okay, and they're not. The reason they look like they are decreasing is because the bars have been put in decreasing order. Right? If you want to see how things are changing over time in this chart, it's actually really, really difficult. Okay? And as someone else has pointed out in the chat, yeah, the legend's not in order. Okay, um, it's kind of hard to match these up, and they keep changing orders. Okay, so it's really important to think about ordering categories appropriately. Okay, so the default for a lot of software, whether it's sort of R or Excel, is to either plot the categories in the order they appear in the data or alphabetically. Okay, so this is a default ordering in R. It's sort of alphabetically going upwards. Okay, and there's sometimes an argument for that. Okay, sometimes you want to be able to find something in a big long list, and it's easiest to find things alphabetically. Sometimes magnitude ordered is more important. Okay, so you need to rank things and see what's at the top of the list. However, if there's a natural ordering to those categories, that's usually the most important thing. Okay, so in this example, it's looking at different days of the week. Okay, and there's a natural order to those days of the week. We go from Monday through Sunday, and when you sort of use that natural ordering of things, you start to pick out patterns much more easily. Okay, so here, days of the week, it's over time, there's a natural order, and straight away we pick out that weekend pattern that Saturdays and Sundays are different. Okay, so we need to make sure that we're ordering categories in a way that's appropriate. Here's another example, still looking at GDP data. Okay, so if I asked you, for example, how does the GDP of Portugal compare to all of the other countries? Okay, now technically you have all of the information you need to answer that question. Okay, but with this type of chart, it's basically impossible to find that data in this chart. Okay, so if I wanted to look at Portugal, I'd go to the legend. Okay, they're in alphabetical order. Okay, it's easy to find. So I find Portugal, and it's sort of this shade of bluish purple, which looks really similar to those other shades of blue and purple. And I have no idea which one of these lines is Portugal. Okay, so what I want to do here is actually highlight the thing I'm interested in. Okay? So an alternative way to show this data is to use highlighting. Okay, so I still plotted all of the lines. Okay? I haven't just plotted the line for Portugal here. I've plotted all of the other lines, but they're in grey. Okay? So I can still see how does Portugal compare to other countries. Okay? But it's really easy to find the one I'm interested in. Okay, because it's quite unlikely that someone is going to be interested in the details for every single one of these countries at the same time. We're usually interested in one thing or in a small group of things and how they compare to everything else. Okay. The other ways you could do this is to just show a smaller number of lines. Okay, so calculate an average and then show how does a couple of different countries compare to that average. Okay, you could also use facets or small multiples. Okay, so you could split them out into maybe different subregions. Okay, or as I've done here, use highlighting to highlight the thing that you're interested in. Okay. Here's a different approach. to plotting multiple lines. Okay, so here we have two different variables. We have GDP and we have life expectancy, and I want to show how they're changing over time and how one affects the other. Okay, now something like this chart doesn't really work here because they're on very different scales. Okay, so what I've done here is use a dual y-axis. Okay, so I have life expectancy is on the left and GDP is on the right. Okay, and the colors match up with the colors of the lines. So the only difference between these two charts is the relationship between the left and right axes. Okay, so the right axis is the same in both charts, but you can see that the left axis is a little bit different. Okay, so on the one on the left, when you first see this chart, your your eyes sort of go here. Okay, where do those lines intersect? Okay, so you look at this point and you go, okay, sort of mid or sort of early to mid 80s, something interesting happened there. Your brain does a very similar thing with the one on the right and looks at this point and sort of goes, okay, late 1990s, something interesting must have happened there. That's where these two lines cross. Okay. The time at which those lines intersect means absolutely nothing. Okay. The sort of choice of scaling between the left and right axes is entirely arbitrary. You can choose any value you want. The thing that is going to affect is where those lines intersect. Okay, so that's why dual y-axes tend not to work very well. Okay, because the choice of scaling between the two axes is entirely up to you. It doesn't mean anything, but our brains sort of interpret it as meaning something because we start looking at where did the lines cross. Okay? Quite often, if you're thinking that, okay, I need a dual y-axis chart, okay, how those two things are changing over time is quite often not the thing you're actually interested in. Okay? What you're probably interested in is the relationship between those two variables, right? That's why you're trying to plot them on the same chart. So actually what's more effective is to make a scatter plot of those two variables against each other. Okay? And you see much more easily that as GDP goes up, so does life expectancy. Okay? It's really hard to get that from this chart to look at what's the relationship between the two. Okay? Obviously, with this type of chart, you kind of lose that element of over time. So what you might want to do is do like a connected scatter plot. Okay, so you could join up these points in the order that they occur over time. If you do really want to focus on the aspects of things changing over time, you could do separate plots, each with their own axis, and place the plots side by side, or rescale the variables in some way. Okay, so look at something like percentage change over time. In terms of talking about lines, okay, when we use lines to join up data points, that suggests two things. Okay, it suggests that there's an order to the points. Okay, you're going from A to B, there's a line going from A to B. And it also suggests it's a continuous variable. Okay, so there's something in between A and B. Okay, so if you have categorical variables, okay, so here we have different regions in the UK, it's not appropriate to join them with a line. Okay, there's no ordering between two different regions. Okay, and it's not a continuous variable. Okay, there's not a category that's halfway between the two. Okay, we're going to now talk about colors. Okay, and this was one of my favorite visualization topics. Okay, so why do we use colors? Okay, so when we use colors in a chart, it should really be, again, there to serve a purpose. Okay, so it might be to sort of code different groups of data. Okay, so the line charts, the lines are different colors because each line is for a different group. Okay? You can also use colors for highlighting. Okay, so like that example of the line chart where we highlight Portugal, it tells someone, look at this thing. Color isn't always the most effective way for communicating differences between variables. Okay, so you'll see quite often people using sort of continuous color scales, so sort of like a gradient that goes from red to yellow. And it's quite hard to actually tell the difference between the values and variables when you do things like that. Okay? So when we talk about colors, we usually have three different types of color palettes that we can use for our visualizations. Okay, so you can have sequential color palettes. This is where we have a single color that's getting lighter or darker. Okay. We have diverging palettes. Okay, so it's usually two colors getting darker in opposite directions. And we also have qualitative or discrete sort of categorical palettes where there's no ordering to the colors, there's no relationship between them, they're just completely distinct colors. So we want to make sure that if we are using a color to represent a variable, that we match the type of palette to the type of variable we have. Okay, so if it's a continuous variable, we probably want to use a sequential palette. If we're trying to show how something diverges, so is something above or below a threshold or above or below average, diverging palettes are really good. And if it's different categories, we want qualitative palettes. Okay. So here's an example of a chart. Okay. Again, looking at that GDP and life expectancy data from Gapminder. Okay. So each point represents a different country. Okay. And the points are color coded based on the continent that country is in. Okay. So if you are an R user, okay, if you use ggplot2, you might recognize this as the sort of default palette in ggplot2. Do you think this is a good choice of colors? So it's a default palette. So you might be thinking, well, if it's a default, maybe it's trustworthy. Okay. This is what that palette looks like with different types of color blindness. Okay. So you can see in the top left here in this sort of simulation, um, Africa and Asia, the colors of those dots look pretty much the same. Okay. And similarly in this Europe and Oceania looks again very similar. Okay. And at the moment, color is the only way that we've encoded those different categories. So if you can't tell the difference between the colors, you can't tell the difference between the categories at all. Okay. And I think one of the things that's definitely caught me out in the past is that if you look at this chart in a sort of desaturated, so if you were to print it in black and white, all five categories look identical, okay, because those colors are all equally bright. Okay, so if you are sending a report to your boss and you're someone who likes to look at it on paper and you print it out on black and white, your pretty chart that you spent ages perfecting just looks like a sort of big grey blur. Okay? So we want to make sure that we're using appropriate colors. Okay? And this is another example of a chart where something there's a couple of options for how we deal with this. You could use a combination of shapes and colors. Okay, so you could do like a pink triangle, a yellow square, I don't know, green circle, for example. The other thing you could do in this one is do those small multiples. Okay, so you could, a little bit like the Portugal example, split it out into small multiples and highlight the different categories in different facets. We also want to think about what colors we're actually using. Okay, so different colors have different associations. Okay, so something like red and blue is really commonly used to show hot and cold. Okay, so if you look at like climate graphs, temperature charts, red is almost always hot and blue is cold. So we want to make sure we never switch them to the opposite meaning. Okay, it's going to be really confusing if you use blue for cold and um, red for cold and blue for hot. Okay, it gets really confusing because our brains are sort of used to colors meaning certain things. Okay. It's also very common when you're plotting data for men and women to use things like pink and blue for a similar reason. Okay, but it's important that you think not just about the colors you're using, but about whether there are associations or sort of negative stereotypes associated with that. Okay, so it's becoming more common not to use pink and blue to show women and men, okay, and instead using two other colors, because there are some negative stereotypes associated with these sort of color representations. So my favorite website for choosing colors is Color Brewer 2. Okay, I think there's some R packages and Python packages that give you these colors in R and Python. But it's a very old website. But you can click through it and you can choose whether you want colors that are colorblind safe, print friendly, what type of palette you need, how many different categories in your data you have, and it gives you options for palettes and it shows you what they look like. Okay. So I find this a really, really useful website for trying to choose a good color palette. So when you're using colors in a chart, quite often or almost always you create a legend. Okay, so that shows how does a color map to the different category. And there's a couple of things to be aware of when you're making legends. Okay, so we want to make sure that they're not taking up lots and lots of space. Okay, we don't want them to take up space where we could be showing data and showing something sort of more useful. You can integrate them into the chart. Okay, so using things like direct labels. They should follow the order of the data. Okay, someone commented on that earlier on. That's exactly correct. Okay, the legend should follow the same order as the data. And as we've seen in that scatter plot example, it shouldn't be the only way to match the color to the categories. Okay, so here's an example looking at stock price changes over time. Okay, so we have four different categories. So we have four different line colors. And this is on the left, the sort of default legend you get. Okay, and you can see that it's a little bit confusing because the legend is in the opposite order to the data. Okay, so if I want to know for this line here at the bottom, I have to go to the top of the legend. And if I'm at the top of the chart, I have to go to the bottom of the legend. Okay. Whereas the one on the right, I can see straight away which category is which line because they're directly labeled. Okay. The other nice thing about this approach is that you can see these two lines in the middle. By the end, they're very close together, and it's very difficult to see which one is higher or lower because my sort of categories are listed in order. I can see which one is on top by the end as well. Okay, so these direct labels are more accessible again for people who can't tell the difference between different colors as easily. Okay, and another example of looking at legends is putting them in order. Okay, again, for some reason, the default here is that the legend goes sort of left to right. Okay, alphabetically, but the bars are stacked sort of top to bottom. Okay, so the legend ends up in the opposite order from the data. Okay, so if you couldn't tell these colors apart, it'd be very easy to sort of switch the purple and the green here. Okay, it's quite again a small fix to put your legend in the same order as the data. Okay, so we've gone through quite a few examples of choosing chart types. And sort of applying best practices. So I'm going to give you an example of a chart here. Okay, so this is looking at the number of women who are elected as MPs in the UK at general elections since 1918. Okay, so I'll give you a couple of minutes. Just post in the chat. What do you think is good about about this chart? Um, is there anything you think is bad about it? Okay, so feel free to criticize that chart or to sort of say something that's quite good about it. Okay, so I'll give you a couple of minutes to think about that. Okay, so we got quite a lot of comments in the chat. So let's have a little think about it. Okay, so there's been a few. I think a lot of the comments are around the ordering of the bars. Okay, so I think the ordering is actually okay. Okay, so remember we talked about having a natural ordering for different categories. Okay, so here are our categories are sort of years or sort of years and months. So putting them in order does make sense. Okay, so rather than ordering by magnitude, ordering by year would probably make the most sense here. But as quite a lot of people have pointed out, the years aren't exactly spaced equally. Okay, so at the top we go from 1918 to 1922, so we have a 4-year gap and then a 1-year gap, 1 year, then 5 years. Okay, and so the reason for that is this is when general elections occurred. Okay, so we don't have data for every year, we only have data for every election, and they don't happen at regular intervals. Okay, and that's why for 1974 we have two values because we had two general elections in 1 year. Okay, and it is a little bit weird that we only have months for 1974. There's no reason we couldn't have put months in for every other year. Okay, so let's think about how we could present this slightly better. Okay, so I'm going to try and address that sort of time issue first. Okay, so the first thing I'd do is put time on the x-axis. Okay, for two reasons. One, it is much more common. It's more common to see time along the x-axis than it is up and down the y-axis. Okay, it also fits on a slide much nicer than a sort of very tall chart. Okay? And so straight away, I start to see the patterns of things happening over time. Okay, that I don't really get in this version. Okay, so you can see where there's big gaps. Okay, and it also looks like this is sort of something where it jumps up and then sort of gets a bit flatter. Okay, so making sure that we represent time in this example not as a category but more like a continuous variable. Okay, and that helps you to see where those uneven gaps in time are. The other thing I would change about this chart is the axis limits for the percentage. Okay, so this version of the chart has both the absolute values and the percentage. Okay, I'm going to focus here just on the percentage. Okay, but the range of our y-axis here goes up to the range of the data. Okay, but that's not the possible range of the data. Okay, the possible range for percentage is 0 to 100. Okay, and so that suddenly looks a lot flatter. Okay, it doesn't look like quite as an impressive jump. Okay, and I think one of the things about visualization is that just because you're making a picture doesn't mean you can't also use some words. Okay, so adding annotations for things that are important, that give context, can be really useful. Okay, so the UN recommendation for the minimum percentage of women is 30%. Okay, so let's add a line, let's add an annotation that shows that. Okay, so suddenly this sort of big jump are in the sort of late 90s that in this version of the chart looks like a big jump, it looks impressive. Actually, it's still way below that threshold. Okay, and that threshold has only sort of been passed in the last two elections for the range of this data. Okay? And actually, we can go a step further with our annotations and say this is what it would be if it was representative of the population. Okay, and so adding those additional annotations and adding that context is really important. Okay, it's something that you don't see in this version of the chart. Okay? You don't see how things are actually changing over time. And you don't see sort of what's the context of this percentage. Okay, is that good or is it bad? Is it really changing? Okay, so thinking about how you represent your date, is it really a category or is it continuous? What are the axis ranges? And what other information do you need to really understand the chart and the data? Okay. So the sort of key points around data visualization is that charts should have a purpose. Okay? And the type of chart that you choose should support that purpose. Okay? And that means that you do need to actively design your visualizations. Okay, so rather than just relying on default chart types or default colors and legends, there's usually quite a lot of tweaks and changes you need to make to those defaults um, based on your data and based on who you're presenting that data to. Okay? And as you've seen in a lot of the examples we looked at, a lot of the answers to data visualization is it depends. Okay, so there are rules in data visualization, but those rules should almost always be broken for some types of data or for some types of charts. Okay? So I wanted to end with a couple of examples of some of my favorite charts. Okay, because sometimes when I do talks like this and I talk about best practices, I don't know, it can and leave you feeling about a big list of don't do this, don't do that, and you feel like you have to make just boring sort of bar charts or line charts. But good charts don't have to be boring. So these are a couple of my sort of favorite examples. So this is an example from Cara Thompson. So this is looking at the number of different colors of Lego bricks over time. Okay, um, so it's really easy to see different decades. Okay, and again, it's this sort of stacked bars, and you get straight away the increase over time. Okay, but the thing I love about this chart is how Kara has grouped the different colors together. Okay, so you can imagine if these were just sort of randomly ordered, this would just look like a big blob of different colors. But here she's grouped all the sort of white and grey ones together, all the blue ones together, all the red ones together. So that pattern is much more clear, and you can start to see, okay, what colors are the big increases coming from. This is another really good example of using facets or using small multiples. Okay, and again, thinking about that ordering of categories. Okay, so it's not just about ordering axes, it's about ordering the small multiples. Okay, so you can see here they're ordered from top left. So sort of most above the threshold to least below the threshold, and using those colors to reinforce the distance from that threshold as well. Okay? So it's a really nice example. Instead of having, what is it, like 30 different lines, we've got some nice facets, 30 facets instead. Okay? Another really nice example here from Tanya, looking at the sort of number of Supreme Court confirmations from different parties. Okay? And this is one of the examples where, again, we talked a little bit about things like pie charts. So with this sort of radial axis being a little bit harder to interpret because of the angles, but this is a really effective way of doing it because you can just count up the circles. Okay, it's really easy to look at sort of this one here and just go, okay, how many were red? 5. Okay, so it's radial, it's a nice presentation of data, but it's still really accurate because you can just count them up if you need to. Okay. The last example I want to show you, I think one of my favorite charts from Dan, looking at energy production in Australia, and it's really clear. Okay, and you get this sort of message with the chart because of those annotations. Okay, so fossils down, renewables up. Okay, it's a really quick message. People can remember that. Okay? If you're writing something like an academic paper, I'm not saying this type of chart might fit in there perfectly, but if you're at a conference, you're doing a presentation, you're maybe doing a like nicely presented report, this will be really effective. Okay, so it's got all the values for the data and annotations, it's got years, but the first thing you see and the thing you remember from this is that message. So it's that really nice combination of annotations, giving you the words you want to remember with a chart. Okay, so it's really clear and very nicely designed, I think. So I will leave you with a few different resources, and I'll drop a link to the slides as well so that you have those. So the Office for National Statistics has some data visualization guidance about how we present data, different types of charts, and sort of a lot of best practices stuff. The RSS also has some best practices for data visualization guidance. It's got lots of different examples of charts, some best practices. It's also got some code. Okay, so if you do use R, Python, Julia, it's got some examples in there of how you can sort of style those charts with those different tools. Okay. There's a link here to the visual vocabulary from the Financial Times. Okay. For that visual vocabulary, and there's an interactive one where you can sort of click through different relationships and different chart types. And I've also got a list of data viz resources as well. Okay, that's got all of those links on them and some links to other papers and things like that that are quite useful. Okay, and they're all freely available. Okay, so if you want a link to the slides, they should be up online. But otherwise, we have plenty of time for some questions.
Thank you, Nicola, for the really insightful presentations. And we are now open to some Q&A. We have roughly 20 more minutes for Q&A. And there is a questions in the chat saying that, can you, oh no, you already shared the website. And someone in the chat was asking what would be your recommendation for academic papers, because it might be a bit different from journals like FT or like online.
Yeah, it's a really good question. It's really about thinking, who is your audience? Okay, so something like this chart here. So you have a presentation or it's a newspaper, this will work perfectly well. You could put the same chart type in an academic paper, but it would need to be styled slightly differently. Okay, so you probably have your title at the top, and then your subtitle, and you probably have your sort of date labels in a more traditional place along the bottom, for example. I think in academic papers as well, the kind of statements of fossils down, renewables up. I feel like that's almost kind of more likely to meet with a bit of resistance. Not making those sort of statements within a chart. But in this example, I think it is fine. So the chart type, absolutely fine for an academic paper. It's going to be the styling. Okay, so you're going to have, things like fossils would be as a category down here, renewables here, and showing the two. Okay, so I think when it comes to the difference between academic papers and presentations or like newspapers or reports, choosing the chart type and the sort of the basics are probably unchanged, but it's the styling and the sort of way you present those messages that will change most.
And there are a few more questions. So one is like, what is the best use of the notorious stack bar charts? And also, should we always include arrow bar graphs when we have bar charts and scatter plots? Sometimes as statisticians, we are asked to include this.
Okay, so I'll start with the stack bar charts because that's an easier question. So if I go back to the example that's in here, okay. So I guess there's two things to note about stacked bar charts. One is it's in terms of accessibility, they don't work if sometimes you have categories with a value of 0. Okay, so here you're kind of relying on the ordering of the colors staying consistent. If the orange category for chin strap was actually 0, this would go straight from purple to green. Okay, so you lose that accessibility as soon as any of your category values are 0. So that's one thing to think about. The other thing is that it depends on how many categories you have. Okay, it's a little bit like pie charts in the sense that the more categories you have, the less readable they become. Okay. With stacked bar charts, you can really only compare two things. So one of them is how is a total changing over time or amongst all of the different groups of the bars. The other thing you can compare is how is the value of the category at the bottom, okay, or nearest the axis, how is that changing over time? Okay, it's really difficult if you think about this example. Okay, if we had lots of those orange segments, it's really hard to compare how those are changing over time because the position is changing as well as the width. Um, so I think stacked bar charts are fine as long as there are few categories. Okay, you don't have too many categories, as long as none of the category values are zero. And again, think about the ordering of those categories so that the most important one is at the bottom of the stacking, sort of nearest the axis. Okay. The other part of that question was around error bars. So when we have bar charts and scatter plots. So we have some guidance. I'll find a link to that. That's been quite newly published on our ONS best practices about when you should be showing uncertainty in charts. Right. So it's basically important to include uncertainty. Okay, so things like error bars or showing your confidence intervals, if knowing about that uncertainty would change the interpretation. Okay. So if I was to um, show you 2 points that are quite far apart, as a sort of a non-technical reader, I would probably assume that those 2 points are quite different. Okay? So if the uncertainty around those two estimates is very small, then yes, those 2 points are quite different, and so my interpretation, my conclusion doesn't change when I know about the uncertainty. Okay? So in that sense, showing the uncertainty is a little bit unnecessary. Okay? But if the confidence intervals were very wide, um, then it does change my interpretation because actually, although those points look far apart, statistically they're not that different. Okay, so then it becomes really important to show that uncertainty. Okay, so you should show uncertainty, so things like error bars, confidence intervals, when it affects the interpretation of the chart. Okay. In terms of how we show that, with things like scatter plots, adding error bars is totally fine. With things like bar charts, what we usually recommend is showing, rather than plotting it as bars, plotting it as ranges. Okay, so between um, the lower and upper intervals. Okay, because if you add an error bar onto the edge of a bar chart, okay, so in this example, if I was to try and draw a bar chart, an error bar sort of here, um, they don't work very well for showing uncertainty because only the error bars are only really visible above the bar. But obviously it goes below the bar and people tend not to interpret those very well. Okay, so show uncertainty when it changes the interpretation.
There are a few more questions, and then there are a few questions that were that people entered during the presentation. One is that, how about using a king for axis? And the other one is that, on starting at zero with column charts, how would you handle the visualization if there's outlier effect? Probably a very large one column that make the rest insignificant.
Yeah, two really good questions, and I guess kind of related questions. So if you had one, let me just go through and find an example. Um, so if you had this example, what one, you had lots of um, categories, and one of them was just much bigger than the other. Um, so in that scenario, in terms of those outliers, I'd probably be thinking about, is a bar chart actually the right type of chart, right? It might actually be that something like a scatter plot, where you're just showing the points, makes more sense, okay? And then then it's more appropriate, a little bit like the line chart example, to use a different axis range that doesn't start at zero. I tend not to do the example where you sort of have a gap in the axis, because it has similar kind of problems to truncating the axis and not starting at a zero, in that the height of the bar still no longer accurately represents the actual values. Um, it's again similar to that, even if you are using something like a scatter plot and using that sort of axis with a sort of little kink in it or a little gap, it's something that people don't tend to notice until they've spent some time looking at the charts. I tend to stay away from those personally. The other thing you could do is there's definitely packages in R that do it, and you could do it manually in things like Excel if you wanted to, is to actually show both of these charts. So you would show like this example here, the full chart with the full axis range. But what you could do is sort of, draw a little box around this bit and show like a zoomed in version of the chart so you can see those individual differences if you really needed to. Okay, so there are sort of ways around that. Give the context, but then zoom in and sort of show the detail if you need to.
Thank you. And some questions are related to the software. Like, what is your view on doing analysis and passing results in Microsoft Excel to draw graphs? Like, for instance, moving from SPSS to Microsoft Excel. And the other question is a bit related. It's that some organization requires statisticians to have knowledge on Tableau and Power BI. And could this visualization session to be applied to using this software?
Um, I'll answer the second one's easier. So yeah, so all of the things that I've talked about today, like the examples are in R, but they are general principles that can and should be applied, regardless of what tool you're using. Quite often I start my charts on pen and paper to get that initial design. And you can definitely do these things in Tableau and things like Power BI. So yes, definitely apply best practices regardless of what tool you're using. Um, in terms of like doing analysis in statistical software and then pasting the results into Excel, um, I I don't mind Excel for making charts. I guess there's a couple of reasons I tend not to do it. So one is reproducibility. So if you are, if you're having to make the same chart every month, for a sort of monthly report, or if you're writing an academic paper and you might have to update your results at some point, um, using software like R or Python, um, it makes it easier to reproduce your results and less manual work. You don't have to manually go in and remake the plot every month. And I think anywhere that you're copying and pasting data is it's a little bit risky because there's human error. It's quite easy to accidentally miss a row of data or something doesn't quite copy and paste correctly into Excel and something gets misformatted. Um, so I don't I don't think it's the best way of doing things, but ultimately it's it's better than not doing it. So like we've talked about how visualization is really useful. So any way that you can make visualizations of your data and feel comfortable editing them to apply these best practices is good. Um, but I think, in terms of reproducibility and try and minimize the risk for errors, it's probably not the best way for doing things.
Graph with congested data values. What is your view on using the data table below the graph,
Um,
which is tables in general too?
yeah. Um, I I think it's a good idea. So, um, I'm kind of thinking more with my like ONS hat. But anytime we make a chart, we also make the data available as a spreadsheet. And there's a lot of tools out there that let you click between the view the chart versus view the table. And that can be really useful. Again, for accessibility, if you need to know what the values are, you can look at the table. Um, I think another comment on that is that when you're making a chart, the purpose of it is not always to show every single value. Okay? Quite often you want to show that bigger picture. Or what's the overall trend? Is there a difference between groups? It's not always about showing every value exactly. That's what the data tables are for. So I think any chart should probably be accompanied by data, so that people can reuse that data, can look at it if they want to. If it's something like an academic paper, I probably wouldn't put it sort of below the chart. I'd probably put it in an appendix and say, you can, if you want to see the data, it's over here. So yeah, definitely give people a way to look at the actual values if they need to, but you don't need to present both side by side.
Yeah. And please feel free to raise your hands if you have any questions too. And okay, before that, there's another question. What is the best chart for a survey that consists of states, gender, salary, and order variables on Likert scale?
Okay, so I think for things on a Likert scale, um, it de it depends whether they're looking at. I'd normally look at percentages, and something like a stacked bar chart um, with a diverging palette tends to work quite well for showing the change. Um, Again, it's really important that you think about what's the um, ordering of the different variables. So it's probably something that's going to be ordered by magnitude. Okay, so if you have those different variables, I think, yeah, multiple stacked bar charts would probably work well. If you want to start looking at um, the intersection of those different categories, that's going to get really complicated. So I think, yeah, highlighting what it is you want to be looking at. So, yeah, multiple stacked bar charts, diverging scale, probably looking at percentages instead of counts would be my starting point for that. But again, really depends on the data and what um, values you actually have, whether you get to see um, a trend. With state, you can do uh, sort of small multiples or facets arranged in a grid that represents the region underneath. Um, and that way you might be able to see spatial patterns in the differences as well, um, rather than just having a list of states in alphabetical order. If you make those small multiples in a sort of geographic shape, it's quite a nice way of getting spatial patterns out from that type of data.
Okay. And would a line chart be sufficient when doing trend analysis, for example, from 2014 to 2024?
Um, yes, a line chart of some type is usually what I go for when you're showing things over time. Um, it depends how, um, if you just have annual data, then yeah, a simple line chart is works really well. But if you had something like monthly data, um, over a long time period, sometimes it can be useful to plot um, multiple lines in a chart. So you might have months on the x-axis, and each line would be a different year to see whether it makes it a little bit easier to see whether there's a seasonal trend as well as a long-term trend. Because if you've got lots of years of data and they're all monthly, it can be quite hard to see those seasonal patterns. So zooming in on different aspects of time. But yeah, line charts are that sort of default when looking at things over time.
Any more questions? So maybe I'll ask one question and people can still have some questions. So I think for graphs and news, sometimes you also have to tailor it according to your message. And I wonder to what extent you balance between the scientific rigors versus like how intuitive you can express a message, because sometimes it feels a bit dangerous.
Yeah, and I think it's like there's the phrase sort of data storytelling gets thrown around a lot, and I think to some extent it makes people a little bit nervous because there's the idea of like, what why are you telling a story for the data? The data, speaks for itself. Um, and I think it's really important when you're designing a chart, or just when you're doing research in general, to make sure that you're kind of considering that you're not trying to make the data fit the story. you're finding the story that exists in the data. And if you're doing something like data storytelling, that in some sense would be easier to try and make the data fit whatever it is you want to say. But I think it's also a problem in research more broadly. You could fit particular models that support your viewpoint if you don't choose the model in the right way. The other thing I would say is that data itself is very rarely neutral. So it's choosing not to tell a story and letting the data speak for itself. So if I go back at this example uh, here, right, that's a plot of the data, right? There's nothing dishonest about that plot. It shows the actual values, right? The sort of data storytelling aspect of it comes in when you start showing the context, right? There's nothing dishonest about any of those charts. Okay, they all show the data equally honestly, but you're trying to draw out that message, right? And you're sort of saying what other information or what context does someone need to understand this chart, right? Because there might be things that you, as an academic or as a researcher, that So when you look at the chart, you see something, but someone else who's looking at your chart maybe doesn't have that knowledge. So there's something else that they sort of need to know. So yeah, I think just as with all sort of research, following good research practices and making sure you're choosing the right chart type for the right reason, and adding context where you need it to.
Thank you. And so I have sent the link of the slides to the chat already. And thank you so much. And now welcome Naomi from YASA to give us some closing remarks on the session.
Thank you. Thank you, Teresa. I'm not Naomi. I'm standing in for
Sorry.
Naomi. Hi, everyone. This is Dorcas. I know Naomi's in the chat, but I could give the closing remarks. So thank you, everyone, for joining us today and also engaging on this webinar on data visualization, which was organized by YASA and the Young Statisticians section of the Royal Statistical Society. It's been a fantastic session. I have enjoyed it, and I'm sure everyone else has. And I know that for sure we have learned a lot about how we can communicate data more clearly and creatively. And that is not just about the data type. There is more to consider when we're creating charts as statisticians. Events like these, they really show us the value of collaboration and exchanging skills, and they give us the opportunity to learn from each other and strengthen our community as young statisticians. They also make sure that as members, we continue to acquire skills that make us valuable statisticians in our countries, in our continents, and also globally. So I'd like to thank our facilitator, Dr. Nicola, for taking your time and sharing your skills and knowledge with us. And I also thank the organizing team that was doing behind the scenes from both YASA and YSS, Dr. Naomi, Dr. Sean, Teresa Chukudi, and the RSS events team for all the hard work that you put behind the scenes. And yeah, once again, I apologize for the mix up in the joining link. It was oversight on both our sides, and we will amend that in future. So last but not least, I want to thank you all, young statisticians from Africa, from the UK, and from all over the world who have joined us today. If you're not a registered members of either YSS or YASA, I urge you to join so that you can continue enjoying such sessions even in the near future. So thank you, everyone. We look forward to seeing you again soon in another joint session. probably sometime next year, but look out for other YASA and other YSS events that are happening between now and the end of the year. Thank you, everyone, and have a lovely day ahead. Bye.
Thank you. Bye. And I send a YSS event for next month. Please feel free to join if you are interested. Thank you again.